Hello, welcome to the scenario S3 of our demonstrator showcase here. Here we're going to have a look at the degradation feature of the SORRIR framework. Let's first have a quick look at what scenario we're looking at here. We're going to assume the arrival scenario, which was presented in the previous story, where a customer creates a reservation for a parking space in a smart parking garage. The customer will then approach the SEB with their car. The car sensor will detect the presence of the car. But in this scenario, we now assume that the connection to the camera is interrupted, which means that the license plate of the car cannot be captured here. Now, we're going to have a look at what would happen without SORRIR. Because we have defined this automatic authentication process, which involves both the car sensor as well as the camera module to take the picture. Then we need the plate recognition service to perform an image analysis on the captured picture, the accounting service that stores the accounting information of the customer, as well as the parking management system, which stores the information about the parking slots, basically. And if we now have a single faulty or unreachable component in this process, the system might end up in an inconsistent state, and the customer might be heavily irritated. So let's have a look at what would happen if we have SORRIR enabled here. Now, what we can do is we can define multiple operating modes for the SEB. First, we're going to have the operating mode automatic, which basically executes this procedure as described. So we have this automatic authentication process. Then we're going to have a manual authentication mode where the customer can identify themselves with an ID card. And then we have the operating mode off, where no interaction is possible, but the smart entrance barrier will clearly indicate that it's not functional. Now, what we have to do is, for each operating mode, we have to define a dedicated state machine. We have a predefined set of components, so the components that interact in this process, and we're going to assign a degradation level for that. So now let's have a look at what this looks like in this scenario. So on the left, you can see the state machine for the automatic process. The SEB is first in the state idle, where it waits for a car. If the car sensor then reports a car detected event, it switches its state to the waiting for the camera module, because it has to take a picture, which has then to be resolved by the plate recognition service that performs an image analysis. Afterwards, we can query the accounting service to get the customer's account data. And this will then be used to query the parking management system for any reservation. And if it finds a reservation, we can resolve that and the arrival is successful. Now, let's see what happens on the right side here. So this is the manual authentication process. And you can see that we have omitted the two states waiting for CM as well as waiting for PRS, because instead of capturing the license plate, the user just provides an identity card in the first step, and we can directly use that information to query the accounting service. Now, what we have to do is we have to define a state mapping from the two state machines. And what we do is we fall back from the waiting for camera module as well as waiting for plate recognition service to the idle state. And the SEB will then just display that the customer should authenticate themselves with their ID card. And we can directly map the other states because they're present in both the state machines. Now the question is, how can we detect faulty components here? So what we employ is something called a shadow agent, which is present on each unit. And it basically monitors all the components that are deployed in that unit and will periodically exchange updates with other shadow agents. Now, obviously, the connection between the shadow agents might also be corrupted, but this can be detected by heartbeat messages, and the shadow agent of the remote unit can just assume that the other unit is not reachable. And in this case, it automatically triggers the degradation mechanism, which will then preserve the system state. And now we're going to have a look at the demonstrator front end to see how this is in action. Okay, now let's have a look at how this scenario will look like in our demonstrator GUI. As you can see, we already have a reservation in our parking management system here for the user account SORRIR2. And now we're going to simulate that the user is approaching our barrier with their car. So what we're going to do is we're going to send a car detected event to our smart entry console. As you can now see, the smart entry console changed its state to waiting for camera module here. And now we're going to simulate that the camera is failing. So the connection to the camera is failing by disconnecting the unit. The camera is now marked as unreachable here. And as you can see, the smart entry console automatically changed its operating mode to manual, and its internal state fell back to the idle state. So we'll now display some text indicating that the user should manually authenticate themselves with their ID card. So what we're going to do is we're going to provide our card here using our user simulator. So this card basically contains the account ID. And as you can see, our arrival has now completed because we can use the card to authenticate here without having the automatic authentication process. And we will just complete this process here by sending another card detection ended event, which indicates that the car passed the barrier. And as you can see, the barrier is now in idle. And if now the camera becomes available again, we can simulate that by just restarting it here. You can now see the camera is okay again, and the smart entry console automatically changed its operating mode back to automatic. So the next customer can simply enter the smart parking garage using this automatic authentication process again.